9.3, separable differential equations. Essential question, can I solve a separable differential equation? What does it look like? Well, it's a differential equation like this that has a product of an x expression times a y expression. Now what we're going to do is we're going to have all the y terms on one side and all the x terms on the other side with the differential, and then we're going to integrate both sides. And in some cases, we are able to solve for y in terms of x. Now, why does this work? Well, let's take the answer that we had and take the derivative on each side. And when we do that, we get back to what we started with. All right, let's go ahead and start. This is a differential equation in terms of x and y, and what I'm going to do is I'm going to gather up all the y terms on one side. So this will be y squared dy, and all the x squared x terms on the other side. Okay, and now I'm going to integrate both sides. So I'll integrate y squared dy equals the integral of x squared dx. This will be y cubed over 3 equals x cubed over 3 plus c. Now I could have done plus c on both sides and then I could have gathered up the c's and just put them on one. Okay, we want to find the solution for this equation that satisfies the initial condition 0, 2. Okay, 0, 2. So everywhere I see a y, I'm going to write 2. That'll be 8/3. Put a 0 here for x, and c is equal to 8/3. So my solution looks like this. Now in this case we can go ahead and solve for y. It wouldn't be hard to do that, and if on an AP test it says to solve for y, you go ahead and do that. Otherwise you can leave it the way it looks right here, and you can see that here are the solutions here, and they all look like they're functions. So we can write y in terms of x. Here is another differential equation that's separable, and I just went ahead and showed you the solution instead of working it out myself. And again, we gather up all the y's on one side, the x's on the other side, integrate, and here's our answer. Now this is an expression that I cannot solve for y in terms of x. I can't free y up from the sign without having the y squared inside the argument. So this is a case where I can't solve for y. All right, we're going to solve this equation. Now this says y prime, but y prime is the same thing as dy dx. And now I'm going to have dy, and I'm going to have over y is equal to x squared dx. All right, I'm going to integrate, and when I integrate, I'm going to have the natural log of the absolute value of y equals x cubed over 3 plus c. Now we can solve for y by doing this, by exponentiating both sides. And when we do that, the natural log and the e become, this becomes just absolute value y equals e to the x cubed over 3 plus c. Now I can go ahead and write e to the c times e to the x cubed over 3. And then I can drop the absolute value sign, but when I do that I got to introduce plus or minus. And sometimes what we do is we say, well, this is a constant. Whether it's plus or minus, it's a constant. And sometimes we just say y equals, and we're just some constant c, e to the x cubed over 3. So that's the solution. Now it's a solution if I can take its derivative, and it'll be equal to this. Now here's the solution in terms of a slope field, and also here's the solution that emulates what's going on here in the slope field. So that's the family.